All right, so today we are going to be reviewing how to set up data quality alerts for your downstream machine learning models. But really, today's demo can apply to a lot of different workloads outside of machine learning as well. So, what is data quality? So, data, of course, is a differentiator in competitive markets, and really it's used to drive strategic decisions. It's fed into dashboards and consumption tools, as well as sophisticated machine learning models and more. So, the output of all of these products is really only as good as what you put into them. And so, in other words, they are garbage in, garbage out, but also quality in, quality out. So, data quality issues ultimately result in a loss of trust in data and suboptimal decisions. There are some key benefits to data quality. We're going to focus on the bottom two here. So, consistency. We need to be able to repeatedly apply data metric functions to particular columns so that it's consistent over time and the evaluation happens in the same way over time. And then we need automated measurement. So, making sure that we don't have to go back and manually run anything to check for data quality. This should all be automated at the time that you are assigning a data metric function to a specific table. So, some key use cases that we see, we'll be focusing on the ML ops use case of you have all this upstream data and all of these features that are being fed into your machine learning models downstream. And oftentimes, without any data quality checks, or at least automated, consistent ones, you don't notice that there are data quality issues until your model it looks off or it just breaks. But we also see similar use cases across data engineering in the transformation pipeline. Before your data even lands, you want to check for certain data quality issues. We see data analysts monitoring the tables that ultimately get fed into BI tools, reporting, dashboards, or maybe conversational AI interfaces. It's really data quality on your gold layer before it gets consumed, especially if you're sharing that data internally or even externally via Snowflake Marketplace. And then lastly, we have our data stewards who are responsible for ensuring the quality of data conforms to those business requirements set by the business user. So without Snowflake, oftentimes data quality checks are complex to manage and also introduce a lot of compliance risk. So often these data quality checks involve manually hard coding without the ability to consistently reuse those checks across data sets. They're also often using third-party tools, which implies that you're moving data out to that tool to run some sort of check and then back into Snowflake or into another tool for whatever you're doing with it. So that introduces a lot of security and governance risk as you're maintaining multiple copies of data, not to mention a lot of cost and performance losses there as well. With Snowflake, we strive to make things simplified, they're scalable, and it's all native to the AI Data Cloud. So bringing data quality checks or really bringing any workload into the Snowflake environment implies that you're already in the security and governance perimeter of Snowflake, where you have your RBAC controls, dynamic data masking. Any of that security and governance would already be applied. It's also a simplified process. So we have built-in, out-of-the-box data quality monitoring tools that I'll show in just a moment. And it's all with the scalable infrastructure of Snowflake behind the scenes. All right, so let's jump into a quick demo. Here we're just setting our context, our database and schema, and then I'm creating this users table, and let's go ahead and look at what that users table is. So we have first and last name, we have their email address, phone number, and an ID column. And you can already start to imagine some of the data quality checks we're going to want on this table. So if these are features being fed into a machine learning model down the pipeline, we probably want only those with valid email addresses for one. This email address at the top, it doesn't have an @ symbol. It's not a valid email address. So let's create a data metric function for that. That's not one of the built-in Snowflake core functions, so we'll create a custom DMF called invalid email account, or invalid email count, and we're just checking whether the email address conforms to this regular expression. So an @ symbol in the middle followed by various characters. So we'll create that data metric function. And then we're going to do an alter table statement on the users table. We'll set the data metric schedule to be every 5 minutes. You can do shorter than that, you can do longer than that. It's all configurable by the user, but I would like it to check for invalid emails every 5 minutes. Before we assign that data metric function to our table, let's just take a look at what it produces. So here I'm calling the function from a SQL statement. So select invalid email count, and I'm going to feed in the email column from the users table. And you can see that there's one invalid email, and that's the one that we saw earlier without the @ symbol. I also want to check the null count on the email column. I want to make sure there's no nulls, because that would really impact my downstream models. And here, this is just a Snowflake core DMF function. I didn't have to write anything for that or define it. I'll just go ahead and call the one that's built in. There are 0 nulls in that column, which is good news. Let's also check for duplicates, but I'll use the ID column that is supposed to be our unique primary key for the table. And here we can see 2 duplicates, which will be a problem downstream for us. So let's go ahead and add these DMFs to the table itself. So here's another alter table statement, and I'm adding a data metric function to the users table on various columns. So first, I'm adding the null count function on the email column. Then I'm adding the duplicate count function on ID column. And then I want to check for some invalid emails on the email column as well. These could all be separate statements. Here I'm combining them into one for just simplicity, but you can always add more functions later to a single table. You can see here that a table is automatically generated when a DMF is applied to a table. So we have this table called Data Quality Monitoring Results. And here we can see all of the DMF runs, so the timestamp associated with it, the table name, here it's the users table, the schema database, as well as the column. So the argument here is ID column, and we can see that the metric name was duplicate count, and it found 2 duplicates. Here we're using a system function that's just built into Snowflake called data metric scan. We're specifically scanning for duplicate count on the ID column, and we can pop up the actual records that did not pass the test. So we have 2 IDs that say 8550 and 2 that say 8136. So 4 columns making up 2 duplicates, and we see the problem rows right there. Here we're just creating a notification integration for us to be able to receive an email. And we'll use that integration right here in the alert. So create an alert called invalid email alert. And this will check the table that we just looked at above, data quality monitoring results. It'll check every 1 minute to see if there's any new ones that pop up with a value greater than 0. So if it returned any invalid emails when it checked since the last time it checked, then we will be alerted. It will send an email via the email integration we just created to my email address with the subject line invalid emails found and the body saying we found some invalid emails in the users table. Then we execute that alert, and because the data metric function only runs every 5 minutes, we don't really want to wait around 5 minutes on here to get an email. So instead, here's a past email that I've gotten from Snowflake Computing with an invalid emails found subject line and the body saying we found some invalid emails in the users table. So I can act right away when the data quality issue occurs before that data gets further in the pipeline, instead of waiting around for the model to train or inference on bad data. Jumping back here, so we went through this workflow of creating a custom DMF for invalid email account or invalid email count, but you could also just use one of the built-in DMFs like null or duplicate count. You then associate that data metric function to a table and a specific column, and you schedule the frequency that you'd like it to run on instead of you manually trying to run that DMF yourself. You can then query the results that are recorded in that centralized table that automatically gets added to the Snowflake database in the customer's account. And then you can use Snowflake alerts to set up monitoring based on the data metric function query results. So this could be an email, it could be a Slack notification, it could also trigger a task that maybe retrains your model if something indicates that needs happening. So there's a lot of different things that you can trigger in response to data metric functions failing. But in our case, it was just going to alert us via email.